Okay, let's have a look at topic mensuration. This topic in DSE, you will see it in the paper 1 in usual section A2 or some easy question in A1. So you see that A1, A2, you can find some of the question about mensuration. And this part is the first part. So we have a look two-dimensional question about mensuration. So let's have a look now. Here, about the arc length and the area of sectors. Do you remember? Arc length, that means it's a circle here, and arc AB here. That means it's a part of circumference. Only this part. So we take 2 pi r as a circumference, that means a whole circle. Then arc AB, that means a partition or a fraction of a circumference. So take theta over 360, then you can find the arc length. So as a result, perimeter of a sector OAB, that means besides the arc AB, here is the arc AB, you still have 2 radius. So arc AB here, and then 2 radius. So perimeter of a sector is the arc AB and plus 2 radius. Okay. Then how about the area of sector? Area of sector OAB, that means part of the area of circle. This is a circle area, pi r square. And how many? Okay. So theta over 360. This is the fraction. Okay. So theta, that means this part only. Okay. So when you find the arc length or find the area of sector, that means you find the part of circumference and part of the area of circle respectively. Okay. Some question related to the arc length and the area of sector in DSE question. And when we solve some mensuration question, we use some similar triangles and some triangles with an equal height. Okay. About similar triangles, do you remember their relations with the length and the area? Yeah. For example, these two are similar triangles. Sometimes you have this kind of similar triangles, A1 and A2. A1 is the smaller one, A2 is the bigger one, whatever. You found that, okay, if you have the length L1 and L2, okay, then area ratio, actually we can find it from the length ratio and the take square. So A1 over A2 or A1 to A2. Then you can take it as, okay, L1 over L2 take square. Okay? Okay? You can find it from the length. And in the same time, if you know that these two are the similar triangles, then remember the corresponding sides with the same ratio. For example, A1 related to A2, B1 related to B2, and C1 related to C2. Take either one of them. Take the ratio and then square, we'll find the area ratios. Understand? And other kind of triangles with the same height, that means this one. For example, triangle ABC and the triangle ACD. You know this triangle with a base BC and a height H. And this one with a base CD and a height H. So if you want to find the ratio of the area, then let's write down the area. 1 over 2, okay, 1 over 2 times BC and then times H for the area of ABC. And then 1 over 2 times CD times H is the area of ACD. Okay, ACD. Then, if you know this two, then simplify. no more 1 over 2, no more h, so you found that this one is BC over CD. So if we now have two different triangles with the same height, then area of these two triangles actually just equals to the length BC to CD. Then ask you one question. How about the area of triangle A boy dog, that means the bigger one, to area of ABC, that means this one? What do you think? Yeah, correct. ABD, that means BD, right? ABC, that means BC. They have the same height also, right? So the area ratio will become boy dog to boy C. Okay, think it. 1 over 2 times BD with the height, and this one 1 over 2 times BC with the height. After simplified, no more h, no more 1 over 2, you get this one, right? So if they have the same height, then we can use the length of BC and BD, BC and BD. Then you can find the ratio of the area. Understand? Okay, let's see some examples about arc length and the area. Okay, in this notes, try by yourself for the question 1. I will discuss with you this question. This question seems like the DSE 2015 that year, question number 9. You can finish this one and then try this year question number 9, this question. Okay, let's see. Now the radius and the area of a sector are 15 cm, that means the radius is 15 cm, and area of sector is 40 pi cm square respectively. Ask you to find the angle of the sector. No figure, so I draw it by myself. Here is the angle of the sector. Maybe I let it be theta. This is the first question. Find this one. B. Express the perimeter of a sector in terms of pi. That means you need to find the perimeter. Do you remember just now we talked about the arc length, area of sector, or perimeter of a sector? Yeah, so let's see. First, I let theta be the angle of a sector. Okay, then can you set up the equation related to arc length and not arc length, it's the area of sector with the radius or with the angle of the sector. Yeah, area of sector actually related to theta because area of sector is part of the area of circle. It depends on the theta, right? So I think you remember, right? So you found that here. Pi r square equals the area of circle times theta over 360. Then this one is the formula of area of sector. So now we know that this one radius is 15. So substitute 15 into r, then you need to find this theta. So as a result, the angle of the sector is 64. 64. Clear? Okay. Let's have a look. Express the perimeter of the sector. Okay, so remember you have arc length. Oh, maybe I use this one. Yeah, arc length, right? So here you know you need to find the arc length, and you still have two radius, right? So perimeter of the sector equals 2 pi r times the angle. Now here is 64 degrees over 360 degrees, right? And radius is 15. So 2 pi r circumference times parts of the circumference. It becomes the arcs, okay? And 2 radius. So as a result, 16 pi over 3 plus 30 cm. Okay? Remember, each time check the units. Check the units. Okay? See? Let's go on to have a look. Next question. Okay, I will let you to do question 4 by yourself. Okay, maybe you can stop here and do question 3. Later on, you can check by this video. Okay. Okay, you can pause now if you do it. Now I will go on. Now, sector OAD, that means OAD. Okay, this is the sector, that means the bigger one. Okay, whole is the whole one. It's a thin metal sheet, and sheet ABCD is formed by cutting away the small sector OBC. Oh, cutting away this one. Okay, that means this one will cut away. Okay, then form from the sector OAD. Okay, from this original OAD, the bigger sector OAD shown in the figure. If AD are 28 cm, this one is 28 pi cm, and the RBC, that means here, okay, is 16 pi. Okay, 16 pi. And OA, you know that this one, okay, OA is 21 cm. Okay, let's see the question. Find theta and the length of OB. Find the theta and the length of OB. That means small sector radius. Okay, the radius of the smaller sector. Okay, so how to do it? Now you know the arc length of the longer one and the shorter one also. Okay, so by using the longer one, because you know the radius of larger sector, so you just need to find the theta. Okay, remember, arc length formula is 2 pi r and then times theta over 360. Do you remember? Yeah, so let's try this one and then to have a look. Now here, 21 is the longer radius. Okay, 2 pi r here times theta over 360. So 28 pi, right? So theta equals 240. That means this angle is 240. Okay. Oh, one more thing, remember, the sector may be like this. Okay. However, maybe the theta greater than 180 degrees. So this one also is a sector. Okay. So now you see that this is 240. Okay. A reflex angle. After you know this one, and this is 16 pi for the RBC. So from RBC 16 pi, theta 240 degrees, we can find the radius, the smaller radius. So let's see here. Yeah, that means 2 pi times the radius OB times 240 over 360 equals 16 pi, right? So OB is 12 cm. So now we know theta is 240 and OB is 12 cm. Clear? That's great. B. Find the area of ABCD. That means you need to find as, okay, ABCD. This one. Okay. This one. Clear? Yeah. So you see that how to find this part. How to find the area of this part? Yeah, the bigger sector minus the smaller sector. Good. How to use the formula of area of sector? Okay, area of sector. Do you remember? Can you answer this one? Formula of the area of sector. Yeah, circle area times theta over 360. Correct. So let's see. Okay, here we have two sectors, the bigger one and the smaller one. So the answer, bigger sector area minus smaller sector area. So 21 is the bigger one and smaller one. Just now we found OB is 12, so minus 12 squared. Okay, so at the end, 198 pi cm square. Remember, once again, remember you have to write down the units. Area cm square. Okay, if area cm square according to the given length is cm. So arc length, let's see, cm. OB is cm. And the theta, 240 degrees. So remember, don't miss the units. Okay, so question 4, I left it to you. Okay, try to do it by yourself first before you goes on to have a look at the video. Okay, come back now. Finish. So let's see the answer of question 4 here. Now, zeta OSR, see? OSR, that means the bigger zeta, okay? It's a thin metal sheet. Sheet PQRS, you see? Formed by cutting a zeta OPQ from the zeta OSR. Cut the smaller one, okay, from the bigger one. And you know that this one is x degree. This time, you don't know the degree x. But you know here is 24 and here is 48, okay? OP, OQ, they are the same length, okay? Because you can think it as a radius, right? And SR, you know, 18 pi. So how to find x? Yeah, sure, this one comes from the SR, this one, and use the longer radius. So yeah, let's check. So here 2 pi times 48 plus 24, this is the whole radius, okay? And you get 18 pi as the arc length. So x over 360 degrees, you found that x is 45. Okay, should we write down here degree? The answer is no, don't write it because x degree already. So this time, no need to write degree, sign. Part B, find the area of PQRS, this one, okay? How to find it? Yeah, the same as above, right? Bigger zeta area minus smaller zeta area. So you see, bigger one, 48 plus 24 as a radius, take square, pi r square, times 45 over 360. Here, smaller 48 square, and then times 45 over 360. So as a result, 360 pi cm square. Clear? Clear? Okay. Question 5 here, okay, you can see is a DSE question 2017. Okay. This question again related to some zeta question, okay, but including the congruent triangle this time. Do you remember congruent triangle with certain reasons? Yeah, there are 5, right? Do you remember all of them? Let's see. Here are 5 reasons, okay? SSS, SHS, ASA, AAS, RHS, right? How about similar triangles? Do you remember how to prove similar triangles? There are 3 reasons. Do you remember? Yeah, let's see. You have AA or AA, this is the first one. 3 sides proportion, or the last one. 2 sides proportion include the angle, okay? 2 sides proportion include the angle, that means you have 2 sides in the ratio with the include the angle, that means this angle, okay? Here are 2 triangles, okay? So in question 5, how to do it? Ask you to prove this one, so think about this one. ODG, this one, and the OFG, this one, okay? How to link up them? Let's mark it, because this one ODEF is quadrilateral, okay? Quadrilateral, such that OD, OE, OF are equals. OD, OE, and OF. So this 3 lengths equals. Then OE, DF intersect at G. given that these two angles equal, ODG, FOG are equals angles. Prove this one. Here is a common side. Yeah, you better to write this one at the first. Okay, given length and given angle are the same. So as a result, this time this. They have the common side, OG, okay, common side. And the DOG, FOG angles are equal because it's given. O dot OF given. So at the end, SAS are the reason of two triangles. They are congruent. Understand? Part B. It is given that O is the center of a circle which passes through DEF. Okay, so you see the red circle here because O is the center and then passes through OD and F like this. And now OD is 45. Okay, and EDG is 16 degrees. Okay, then how to do it? Okay, if O as the center, that means here OD, OE, OF can be the radius of a circle. Okay, they are the radius. Okay, OD, OE, OF. Then can you see that here comes from two circumference, E and F. So EDF and EOF. Can you see that this is the angle at circumference and this is angle at center, right? So yeah, very good. If we want to find the theta area, ODEF, this theta, we need to find out the angles here. Okay, then do you know how to find the angles here? Angle EDF is 16 degrees. That means this one related to 16. Yeah, 2 times, very good. So you see that here. EOF, okay, EOF. Actually, it's 2 times of EDF. Okay, angle at center twice angle at circumference, right? So 2 times 16 degrees. Okay, 32. And then DOE. DOE actually same as the EOF because corresponding angles of the congruent triangles. So the angle that we need to find is DOF, 2 times of 32, so 64 degrees, right? So as a result, area of theta here. Okay, you see that? 4 pi times, okay, R square. And then times 64 over 360, then you get 360 pi. Clear? cm squared. Remember the units. Okay? So try by yourself for the question 6. Okay? See? Try by yourself.